assignment 1. So a couple of students have asked me about question 1, so I will start with the discussion of that. So question 1 is saying that you have two displacements which are of magnitude 3 meters and 4 meters. Okay. So how can they be combined so that the resultant is either 7, 1 or 5? Okay. So it is given to us that, let's say, E is a displacement vector of magnitude 3 meters and B is a displacement vector of magnitude 4 meters. So in the first case, it is given to us that the resultant, which is the sum of A and B, is such that it has a magnitude of 7 meters. So then what can we say about the individual vectors A and B in that case? So we have to understand. So we can just use this, that the magnitude of R, which is magnitude of A plus B, will become root of A square plus B square plus 2AB cos theta, where theta is the angle between them. So you can see the magnitude of the resultant is 7. On this side we have 3 square plus 4 square plus 2 into 3 into 4 into cos theta. Okay. So from this you will see that if you solve this, you will get cos theta as 1, or basically they are parallel, or theta is equal to 0. Okay. So you can see that 49 is equal to 9 plus 16 plus 24 cos theta. So that will show you that cos theta is equal to unity, which means that theta is equal to 0, which means that vectors A and B are parallel. Okay. This is a sort of very mathematical way of solving the question. If you just pay attention to the values, you'll also understand that directly. Okay. So alternately, or you can see that magnitude of A plus B is equal to 7. In this case, that is equal to A plus B. Okay. So that means that the vectors have to look like this. This is the vector A. Then the vector B has to be parallel to it, so that when you add them up, the resultant becomes 7. And this has to be the case. You have to realize कि vector B अगर magnitude 4 का है और vector E अगर magnitude 3 का है, but their resultant is 7. Okay. The resultant is equal to 7 in magnitude. That means they have to be parallel vectors. You can understand that straight away. Okay. Yes, that is correct. That Anmol, what you are saying is correct. Whereas in the second part, if the magnitude is 1, they have to be opposite each other. They have to be anti-parallel. Okay. So if you just visualize this diagram, then you can avoid doing all this calculation. If you just noticed that this happens to be magnitude of A plus B, so you know that this implies that they are parallel vectors. Agar magnitude of A plus B, magnitude of A plus magnitude of B के बराबर है. So this implies that they are parallel vectors. Okay. Similarly, for the second part, you can see that the resultant magnitude is given to us as 1. So that can only happen in this case, where suppose A is a vector like this of 3, then the resultant of 3 and 4 can be 1 only if B is a vector like this of magnitude 4. That's the only way it can happen. That then the resultant will become 1 meter. So that means they are anti-parallel. You can see this angle is 180 degrees. Okay. So this can only mean one thing, okay, that magnitude of A plus B is equal to magnitude of their difference, which is 1, because A was 3 and B was 4. So this means that they are opposite in direction, or what we call anti-parallel vectors. Okay. Or that theta is 180 degrees. That is the mean. However, if you want to solve by algebra, it's again the same thing. You can just expand this once again. So this time when you solve, you will get cos theta as -1. Okay, so if you substitute magnitude of A plus B as 1, so solving this, you will by the same method get cos theta as -1, which means theta is 180 degrees. Okay. Now this value also we understand why, in case you want to understand that how come cos 180 kitna aata hai. So we just use the formula that cos theta is equal to minus of cos 180 minus theta, second quadrant. Okay. So therefore I can write cos 180 as minus of cos 180 minus 0. Okay. Sorry, 180 minus 180. Because I'm substituting theta as 180. So that becomes minus cos 0. That becomes minus 1. Okay. So that's a way to understand how this comes. So hope the first two parts are clear of question 1. Now moving on to the third part, where the resultant is of magnitude how much? 5. Okay. So for the C part, you have to solve for the situation where the resultant is 5. Yes, Anmol, that is correct. Resultant is 5 means that, so you can see that magnitude of A plus B is 5 and mod A is 3, mod B is 4. So one way to understand that, since 5 is equal to square root of 3 square plus 4 square, that means that you are dealing with the right angle triangle. Immediately you understand that you are dealing with the right angle triangle. तभी हो सकता है उसका third side 5 जब angle उनके बीच 90 है. That's the only way this is possible. So the resultant can be of magnitude 5 only in the scenario where because as you know it's a Pythagorean triplet 3, 4, 5. So that means they are perpendicular vectors, or theta is equal to 90 degrees. Or you can use the same way of solving. If it doesn't strike you on just looking at the values, that is Pythagorean, so you just solve it this way then. So again in this you substitute this as 5, and in this you substitute A as 3, B as 4. So solve this whole thing, you will get cos theta as 0. So you know that theta is 90 degrees. That's the algebraic way of solving. That's this one, whereas this is geometry wise. Alright, so hope question 1, all 3 parts are clear to people. Okay. So question 2 nobody has asked so far, so I'm assuming that you people are clear with question 2. If anybody has a doubt in question 2, please let me know, okay, over the chat, so that I will discuss that. Okay. Now question 3 is the next one in which I have got some doubt from people. So let me discuss question 3. So question 3 is saying that the resultant of 3 vectors is 0. Okay. And they are of individual magnitudes 12, 5 and 13. Oh, sorry, it is given that A plus B is equal to C, not A plus B plus C 0. That is given. And magnitude of A is 12, B is 5 and C is 13. So we have to find theta, that is the angle between A and B. So this is actually very similar to the third part of question 1, because you will notice that 12, 13 and 5 are a Pythagorean triplet. So you can directly see that the angle should be 90 degrees. So you can see over here that 13 square is equal to 12 square plus 5 square. That means magnitude of C square is equal to a square plus b square. Okay. So that means that c is equal to root of a square plus b square, and c is nothing but a plus b is magnitude. So that means this quantity is equal to the root of a square plus b square, which means that cos theta is 0, which means that they are perpendicular. So as I said, it's the same question, exactly the same method, same type of question as the third part of question 1. Assignment 1, Prince, the assignment which I sent on the group earlier, that assignment. Okay. So we have covered up to question 3 so far. Now I'm coming to question 4 next. Oh, sir, somebody who's noting down, I'll just allow them to finish. Okay, those who have finished writing this down, go through question 4 and tell me how to solve it. Or if you solved it, tell me the answer. Which one, Prince, you're not getting? You've not got the assignment? Prince, it is there on the Yellow House group. Okay, I will resend it. Okay, just log on to that Yellow House group. Okay, Prince. Yellow House WhatsApp group. I'm resending it. It's there on that group as such. Question 1, last part. Okay, I'll show you that also. Okay, so people, just I'm scrolling back now because some of you are still going through question 1 part C. So this was what the part C was, that magnitude of A and B are 3 and 4 and magnitude of the resultant of A and B is 5. So what is the angle between the vectors? This is what we have to solve. Okay, so that is why it is same as this. This is question 1C part. Okay. I have resent the assignment for those who might not have received it. So please, if you can be on the WhatsApp group of Yellow House. Okay, good. So next we are going to discuss question number 4 of this assignment. Okay, so just finish going through this question 1C part, then we come to question 4, also question 3. Okay, good. So now just quickly go through question 3. It's the same type of question as question 1C. You can see it's exactly the same concept actually. Only the values are different. So finish writing this down and quickly go through question 4 next we'll discuss. As a question 3 also we have to discuss. नहीं देखो बेटा, C में क्या, it's given to us that the vector C is equal to vector A plus B, no? This is given in the question. So that automatically means that magnitude of C is equal to magnitude of A plus B. Okay. So that means that magnitude of C is equal to root of A square plus B square plus 2AB cos theta. So this is all coming from this thing which is given. This is given, so from that we can infer this statement. So from that we can infer this statement, and now we can substitute the values. That this is 13, and these are 12 and 5. Okay. So this is becoming plus 120 cos theta. But when you solve this, you will see that cos theta will come out to be 0. नहीं अरे बेटा mod sign is not used, तो मैंने mod लगाया ना. See, if I say that vector A is equal to vector B, it implies, this sign here means implies. तो इसका मतलब भी क्या है, that magnitude of A is equal to magnitude of B, okay, and their directions are same. That is the meaning of two vectors being equal. Now, when are two vectors equal? When their magnitudes are also equal and their directions are also same. Okay, so it's not given in the question, but we have to infer that. The question से मुझे ये meaning निकालना है कि ये vector अगर ये vector के बराबर है, if the left hand side is equal to right hand side as vector quantities, then definitely their mods will also be equal. Understood now? Like that. That's why. Okay. It's like, if I say that 4 square is equal to 16, that means square root of 4 square is also equal to square root of 16. So it is something like that. If I say that x is equal to 3, it means that mod x is equal to mod 3. Or if I say x is equal to minus 3, then I mean that mod x is equal to mod of minus 3, which is 3. So it's like that. So if two things are equal, then their magnitudes are also equal. That applies for vectors also, not just here, applies for vectors. Okay, so let's come to question 4 next. So question 4 is saying two forces of equal magnitude act at a point. The square of the resultant's magnitude is 3 times their magnitude's product. Find the angle between them. The question is, I'm discussing the questions for which students have sent me doubts. If you have any questions you want to discuss, you can also send me by WhatsApp. Okay? So two forces are acting at a point. So let's say force E and B are two forces of equal magnitude each. Okay. So let's say mod A is equal to mod B is equal to some small a, suppose. I just assume that because they are of equal magnitude. And it is also given that the square of the resultant's magnitude. Okay, so if R is the resultant of A and B, then it is given to us that square of the magnitude of the resultant, okay, is equal to 3 times their magnitudes products. So that means that is 3 times E square is what it means. Okay. So this is the meaning of the statement, that the resultant's magnitude square. Okay. So basically what it means to say this statement is that A plus B जो resultant है इसके magnitude का square कितना है 3 times E square. So now we will just substitute that. Okay. So now again use this. So square root of E square plus B square plus 2ab cos theta का square 3a square. And in this substitute A and B as small a respectively. Okay. So this becomes E square plus 2a square cos theta is equal to 3a square. So solving this, you will get cos theta as half, which means that theta is equal to 60 degrees or pi by 3. That is the angle between the two vectors. Okay, now next students have asked me question 7, so I'm coming to that. If anybody has a doubt in 5 or 6, you can ask me. We'll discuss. But otherwise, I'm assuming you have got these questions. Okay, Ramjan. Question 6, I will discuss that. Okay, so a couple of students have asked for question number 6, so I'm moving to that instead of 7. Okay, how you got 60 degrees beta? Okay, so see, Prince, what we've done here is we solved this relation, okay, that the resultant square, that is a plus b ka mod ka square, is 3 times the product of the magnitudes, and the magnitudes are a each. So it's this, okay. So then we substitute a plus b ka mod using the triangle law. So we have expanded from here to here using triangle law, okay. And in this we have put the value of mod a equal to mod b equal to small a. So this becomes, okay, so just next step in this, you put a equal capital A equal to capital B equal to small a, and you get this relation. So next, what you get from this relationship, you're getting 2a square cos theta. Carry these two to that side, so that is 3a square minus 2a square. So that is a square. Okay. So next you can say that cos theta is equal to a square by 2a square. Okay. So it's half. Now cos theta is half means theta is 60 degrees, because we know that from trigonometry. All right. So next we are looking at question 6. So question 6 is basically just about understanding the diagram. Once you will understand the diagram, you can easily find it out. Okay, so it says that a car moves 2 kilometers towards east. So let's say it makes a displacement S1 or something, which is 2 kilometers towards east. Okay. Then it makes a second displacement of half a kilometer. Okay. 500 meters is 0.5 kilometers towards north. Okay. And then again turns 90 degrees and made a perpendicular right turn. Okay. So basically, see, you have to understand this in terms of direction. अगर ये north है और अगर ये east है, okay. So S1 will be a displacement that is towards east. So S1 will look like this. Okay. Then from the direction of S1, the question is saying that you are making a turn towards the left of 90 degrees. So obviously you would have turned this way towards north. Okay. So that's where your S2 is. So you're making a turn leftwards of 90 degrees. You can see your turn is like this to make a displacement S2. And then it's saying that again you are making a rightwards turn of 90 degrees. So if you make a turn towards the right of 90 degrees, from here towards your right will again be towards your east. So that's where from the language of the question we have to understand कि तीसरा displacement जो है वो वापस east की तरफ है. How do I know that? Because the question is telling me that I'm making a 90-degree turn after S2 is completed towards the right. So it will have to be like this. So S3 is like this, and S3 is of magnitude 4 kilometers is going to be. So this is 4 kilometers, this is 2 kilometers, and this is 0.5 kilometers. Now in this diagram you can see what is your net displacement going to be. Net displacement will be this one from here to here. So this will be net displacement. So if you drop this perpendicular here, you can see that this length is 0.5 kilometers. It's the same as this one. Okay. Whereas this base here, this whole thing will be 2 plus 4, 6 kilometers. Okay. So the net displacement is just the hypotenuse of that triangle. So it is square root of the base square, which is 6 square, plus 0.25 square. So that is square root of 0.5 square, not 0.25 square. After squaring it will become 0.25. Okay. So that's why the magnitude of this is square root of 36.25 kilometers. Okay. This is the easy way of doing it using geometry. I'll also show you a method of doing it using component algebra. Which we were talking about last time. So we'll discuss more about that. Yes, exactly, Dushan. We have used the Pythagoras theorem to find out. I've just drawn the diagram and then I've used Pythagoras theorem. ये जो है, this is by Pythagoras. Okay. But yes, I can also use vector component algebra So I'll show that next. Yeah, we just leave the answer this way. No need to calculate further. You can calculate it to a decimal point and all that, but there's no need for that. Medhan, to answer your question, see, any vectors, if its direction changes, the vector itself changes. Okay, so if I say I made a displacement of 5 kilometers towards north and I made a second displacement of 5 kilometers towards east, are the two displacements equal? The answer is no. Those two vectors are equal only if their direction is also same and their magnitude is also same. So if you change the direction of a vector, the vector changes. The vector is not the same. Because the vector is defined by both the magnitude as well as its direction. Okay, now in question 6 only, let us see the component algebra way of solving it. Okay, component method solving it. So in the component method, I would take the north as my y-axis. I would take east as my x-axis. Okay. So my first displacement S1, that would become 2 I cap in kilometers, because it was 2 kilometers towards east like this. Okay. My second displacement S2, which is half a kilometer in this direction, in vector form, in component form, it will be written as 0.5 j cap. Now my third displacement, which is again towards the east, but it is 4 kilometers in magnitude. So in component form, S3 will now be written as 4 I cap, again in kilometers. All of them are in kilometers. So my net displacement S1 plus S2 plus S3. So it will become 2 I cap plus 0.5 j cap plus 4 k cap. So in component form, that will become, sorry, not k cap, it's I cap. So in component form, it will become 2 plus 4 or 6 I cap plus 0.5 j cap. 6 I cap plus 0.5 j cap in kilometers. So this is the displacement net written in component form. So now we have to find its magnitude. So magnitude, we just use the formula of magnitude. It is square root of the x component square plus the y component square. So this will become square root of 36.25. So this is the net displacement's magnitude after solving it by the component method. Okay. So you can just make a note of this if you want. So this was the 6th question, people. Go through it once more and we'll discuss the 7th question next. Yeah, we will solve both the parts of question 7, don't worry. Okay. So first of all, I hope this is clear to all of you. Yeah, I'm scrolling down so you can complete this. Yeah. So here finally we are using that component form, that if a vector E has components Ex I cap plus Ay j cap, then its magnitude becomes this. So ये method use करना. Its components are 6 and 0.5. So its magnitude is then given by this. Okay, so let's come to question 7. So hope everybody is done with this and this question is clear. So question 7 next has a diagram given to us, which I will just put up here so that you understand everything from the beginning. So 7 में with respect to xy axis, two vectors are given to us such that the first vector E is making an angle 30 degrees with the x-axis. Okay, so the first vector E is, let us say, drawn like this. Okay. This angle is 30 degrees, and then with respect to E's direction, you rotate by 120 degrees to that side and draw the vector B. So B is something like this now. Okay. So this angle is given to us as 120 degrees. And it is given to us that magnitude of E is equal to magnitude of B. So this is also 10 units. This is also 10 units. Okay. So now we have to talk about the resultant, what angle it is making with the x-axis. So C is equal to the sum of A plus B. So we have to find magnitude of the vector C and the angle. C's angle with respect to the x-axis, not with respect to E, but with respect to x-axis. So we can do this question two ways. One is we can do this geometrically. So geometrically, if we are solving, we'll use this formula by triangle law formula. You'll see that magnitude of C is equal to magnitude of A plus B. So that is root of A square plus B square plus 2AB cos theta. So in this we'll substitute A is equal to B is equal to 10 and theta is equal to 120 degrees, because we can see the angle between A and B is this one, is this angle. So the moment we do that, we will get C over here as 10. So we get magnitude of C तो ये कितना हो जाएगा, माइनस हाफ हो जाएगा. Okay, because cos 120 is equal to minus cos 60 is equal to minus half. Quadrant 2 formula we'll discuss. So substitute that and you'll see C comes out to be 10. Or magnitude of the vector C is 10. So here if I go back to the diagram, I'll realize that vector C यहाँ पे कैसा दिख रहा है? Vector C is like this, okay, such that C's magnitude is also 10. Okay, so that, yeah, so that means this is an equilateral triangle. Okay. So if it's an equilateral triangle, that means these angles are all how much? 60 degrees. So that means what is the angle of C with respect to the x-axis? It will become this angle, 90 plus, 30 plus 60, so it will become how much? 90. So we can get the second thing, the angle of C with respect to the x-axis, we can get that geometrical unity. Okay. So once we understand this, next we go back to the diagram and we understand that okay, it's an equilateral triangle. Therefore, the angle of the vector C with respect to the x-axis, the positive x-axis, will actually become 60 plus 30. Because वो A के साथ 60 बना रहा है, but A itself is making 30, so it is 90 degrees. So this is the answer to the B part. This is the angle of C with respect to the x-axis. It should be 90 degrees. Remember, it's not asking the angle of C with respect to E. It is asking the angle of C with respect to the x-axis. So that's why over here the answer will be 90 degrees. Okay, people, so hope this part is also clear to all of you. Okay, now we will also do this by component algebra method. We can also do this question by component algebra method. For that, I'd like all of you to try this next. By component method, I want to solve. So what you do is, first write vector A and B in component form, or that is I cap j cap form, and then second step, find the vector C, which is E plus B. So in the same question, do these two steps, all of you. Tell me what is vector A and vector B in component form. How you will write it? Just write this down. Tell me what you will get in component form. Okay. So yeah, Prince, that is what we get for the vector C, not for vector A and B. So let's look at A and B carefully. I said that first we have to write vector A and B properly in component form. So vector A कैसा है? It is making an angle of 30 degrees with the x-axis. No? See, the vector A is drawn over here. It's making an angle of 30 degrees with respect to the x-axis. And the vector B is drawn like this. Now that is also magnitude 10. Such that this angle here is 120 degrees. So in other words, how much angle it is making with the x-axis? If I were to draw a line parallel to the x-axis here, 150 degrees hota. So if I draw A and B properly with respect to the origin, how they are looking. So next step, if I draw in another diagram, the same two vectors, but now I draw them with respect to the origin. So how will the vector A be looking like? It will be looking like this. How will the vector B be looking like? It will be this. This will be the vector B. This will be the vector E. This angle is 30 degrees. Okay. And the vector B is making how much angle with the x-axis? It is making this whole angle, which is 150 degrees. In other words, this angle here is 30 degrees. Okay. And they are both of magnitude 10 each. So this is also 10. This is also 10. Okay. So in component form, when I have to write vector A and B now, I'll have to use these values. So vector A in component form will be, so Ax will be 10 cos 30. So that is 5 root 3. And Ay will be 10 sine 30 degrees. So that will be minus 5. Sorry, that will be plus 5. Okay. So it's 5 root 3 I cap plus 5j. Okay. No need to give the sign also here. You can just see it's 5. But what about the vector B? So for the vector B, you have to understand B's x component is 10 cos 150. So that is 10 into minus cos 30. So that is minus 5 root 3. Whereas B's y component is 10 sine 150, which is 10 sine 30, which is 5. So B is minus 5 root 3 I cap plus 5j cap. Okay, this is just writing a vector in component form when you know the angle and magnitude, the angle with respect to x-axis. Okay. So now vector C is the sum beta. It's not the difference. You know? Vector C is the sum of A and B. So we have to find next thing. We have to find vector C. Now, C is equal to A plus B. So next step, we find C as A plus B. Yeah. So here we are just using the formula that given a vector, if we have a vector which has a magnitude of capital A and makes an angle theta with respect to the x-axis, okay, then its x component and y component are given by the formula E cos theta and E sin theta. So we are using these formulae for both the vectors A and B. Yeah, correct. Anmol and Iitanshu, you got this correct. So Dushant, is this clear? So for the vector A, you can see the magnitude is 10 and the angle with the x-axis is 30 degrees. So x component is 10 cos 30, y component is 10 sin 30. But for the vector B, what is the angle with respect to the x-axis? It is 150 degrees. So the x component, which is b cos theta, will become 10 cos 150. And that's where our second quadrant formula comes in. That cos 150 is minus cos 30. So it's having a negative x component. In the diagram also you can see b's component on the x-axis is negative. वही तो बताया, how did I write I cap and j cap? I found the components ax and ay. Okay. So I found the components ax and ay and then wrote the vector as ax I cap plus ay j cap. Okay. So in this method, what I'm doing is I'm picking up each of these vectors a and b and I'm writing them in component form. How to write a vector in component form? So look at the vector A. The vector A has a magnitude of 10 and an angle it is making with the x-axis of 30 degrees. Okay. So A's x component will become A cos theta. So that is 10 cos 30 degrees. Okay. So that is 10 into root 3 by 2. So that is 5 root 3. A is y component is E sine theta. So that will be 10 sine 30 degrees. So that is 10 into half. So that is 5. So therefore the vector A is what? It is x component times I cap plus y component times j cap. This is called the component notation, which we learned in the last lecture in detail for the vector. So here the value of Ax is how much? It is 5 root 3 I cap plus the y component's value is how much? 5. So it is 5. So now this is how we got the vector E in component notation or in component form. Okay. Diagram mein, what is the significance of these components? They are the projections, or you drop a perpendicular on the x-axis. This is your Ex. You drop a perpendicular on the y-axis. This is your Ey. Okay. So this is the meaning of converting the vector into component form. Now the same thing I will do to the vector B also. So the vector B, when I do that, how is it looking with respect to the x and y axis? The vector B जो है वो A के respect में 120 degrees है. So x axis के respect में कहाँ पे vector B is like this. So this angle is 150 degrees. It was 90 plus, I mean, it was 60 plus 120. Say 30 plus 120. So therefore, with respect to my positive x-axis, it's like this. Because you remember, it's like this. No? If this was our vector E, and vector B was like this, where this angle was 120 and this angle was 30. So that's why the vector B, when you place it here, what is the angle with the x-axis? It's 150. And its magnitude is 10. So you can see when you drop this perpendicular, and when you drop this perpendicular, this is going to be your Bx, which will be a negative component because it's lying along the negative x-axis. And this will be your By. Okay. So Bx is B cos 150, I mean cos theta. Okay, theta here is 150. And the magnitude of B is 10. Now we use the formula from the second quadrant, that this becomes minus cos 30, because we are using the formula that cos theta is minus cos 180 minus theta. So cos 150 is minus cos 180 minus 150. So that is minus cos 30. That is minus root 3 by 2. So it's minus 5 root. That is your Bx. Okay. And similarly, your y component, which is B sine theta, will be 10 into sine 150, which should be 10 into sine 30, which is 10 into half, or plus 5. Okay. Because for sine theta, we similarly have the formula, second quadrant. It's positive of sine 180 minus theta. Okay. So that's why your sine 150 becomes positive of sine 30. It becomes half. Whereas this is minus root 3 by 2. So you substitute that over here. So By becomes 5. So y component of B has become 5. So the vector B in component form is now how much? It is minus 5 root 3 I cap plus 5 j cap. So I've got the vector A and I've got the vector B both in component form. So next thing I can add them and find out their resultant in component form. Yes, that is correct, Iman. So because it is 10 j cap, so it's lying along the y-axis. So what angle it is making with respect to the x-axis? It's making an angle of 90 degrees. Yes. Next step, we want to find the vector c now from this. The vector c is a plus b. So we substitute what we got in component form. So a in component form was 5 root 3 I cap plus 5 j cap, and b in component form plus b in component form was minus 5 root 3 I cap plus 5 j. So ये add होके कैसे हो जा रहा है? 5 root 3 minus 5 root 3, so that's 0. So that's why it does not have any x component. Plus 5 plus 5. So it is 0 I cap plus 10 j cap, or simply we just write it as 10 j cap. So this is the vector c. So you can see that with respect to our xy axis, the vector c will look like what? It's a vector perpendicular to your x-axis. It's lying along the y-axis. यहाँ पे vector b, you vector like this along your y-axis. Magnitude, sorry, vector c. Therefore, it is at 90 degrees with respect to x-axis. That's my final answer. Okay, so that's the 7th question. Just zooming out, giving you a minute to go through this. After finding b, what we did in component form, we added a plus b to find c. Yeah, then so I'll come to question 9. But before that, some students have asked me question 8 also, so we'll discuss. So question 8 is actually quite simple. You have to understand the displacement of the tip of a minute hand of a clock. So let us say this is the dial of the clock. Now the minute hand of a clock, when it is 15 minutes past the hour, the minute hand of the clock looks like this. This is the 8th question. So this is the minute hand at 15 minutes past the hour. And at half an hour, past the hour, or 30 minutes past the hour, it becomes like this. At 30 minutes past the hour. So what is the displacement of the tip of the minute hand? The displacement of the tip is this one, from initial to final position. The tip of the minute hand is having this kind of a displacement. This is the displacement of the tip of the minute. So you can see that if this is 10 and this is 10, 90 degrees. So obviously the magnitude of that displacement will be the hypotenuse of that isosceles right angle triangle. So 10 root 2 centimeters. Similarly, in half an hour, it will go from this position to now this position. So it will become one whole diameter. It will become 20 centimeters in 30 minutes. And likewise, the displacement will be 0 in 60 minutes because it's come back to the original. That is from simple observation of a clock pattern that it's at 90 degrees. Achha, Aditya, you are asking about previous question. So in previous question, see what is happening. The vector C is what it is 10 j cap. Na? So it is along the y-axis. So direction kya hai? J cap along the y-axis. So we know that therefore this angle is 90 degrees. Okay, Aditya, hope this is correct. I mean, hope this is clear. Oh, now coming back to this question. Good. No problem. Now coming back to this question, 8th one. This is the dial of the clock. So we know from observation that the minute hand changes from a horizontal position to a vertical position in 15 minutes past the hour to 30 minutes past the hour. So minute hand का जो tip है, ये arrow का tip वाला point, उसका कितना displacement हुआ है? That is this hypotenuse. So that's why it is 10. Whereas in half an hour, it will reach this position at 9. So it will be exactly opposite. So the displacement will be exactly twice the length of the minute hand. So it will become 20 centimeters. And in 1 hour exactly, it will be 0. So let's come back to where it started. All right, moving on to the 9th question. Now, 9th is a slightly tricky question, so I will discuss in detail. So go through the 9th question. So it's saying that the resultant of vectors P and Q is R. So P plus Q का resultant R. Whereas if I reverse the direction of Q, the resultant of minus Q with P is S. So P plus of minus Q is equal to S. So we have to show that magnitude of R square plus S square is 2 times magnitude of P square plus. So let's understand this in 2 ways. One is we can understand this geometrically. So geometrically, or by using triangle law, you can see that suppose we assume P is a vector like this and Q is a vector like this. And the angle between them is theta. Then by triangle of sum, you can see that this will be the resultant, which is P plus Q. So the resultant will have a magnitude. So this, so that will be root of P square plus Q square plus 2PQ cos theta. So that is my equation 1. Now, what is the second operation? It is P plus or minus Q. First thing we have to understand कि अगर Q ऐसा vector है, suppose Q is this vector, which is making an angle theta with the direction of P. Okay. What about the vector minus Q? What is that vector? So the vector minus Q has same magnitude as Q, but opposite direction. Okay. That means the vector minus Q will be a vector like this. It has opposite direction but same magnitude. This will be the vector minus Q. So it has the same magnitude as the vector Q, but its direction, you can see, is exactly the same. So now I want to do what operation? I want to do P's resultant with minus Q, that is equal to S. So let us draw the triangle for this operation. The triangle for that of this operation will be like this, that the vector P is drawn, and then instead of adding the vector Q, we'll add the vector minus Q, which is like this. So that minus Q vector will show up like this. This is the vector minus Q. It has the same magnitude, but what about its direction? Let's pay attention to its direction. So this angle will be how much now? It will be 180 minus 3. Because original direction of Q was at theta. So this angle kitna ho jayega? 180 minus theta. So now what is my resultant of these two? It is this one. So you can see that magnitude of S become root of P square plus Q square plus 2PQ cos of what is the angle between them? 180 minus theta. So it will become root of P square plus Q square minus 2PQ. Because we use the identity that cos of 180 minus theta is minus cos. So this is becoming your S. So now use equation 1 and equation 2 from above and prove the given identity. Okay, so let's understand our own question from the beginning. So first we are solving this vector operation. Yes, correct. Mind that what we do next. But first we are solving this vector operation through this triangle. Okay, and it's giving us this formula. This triangle, an application of triangle law is giving us this formula. And next we will solve this operation. But for that we first have to understand what is the vector minus Q. So the vector minus Q is this one. This is the vector minus Q. So मैं P में क्या ऐड कर रहा हूँ? Minus Q ऐड कर रहा हूँ. This one. So another thing you could do here directly is you could also interpret this as the difference of the two vectors. You can just directly use the triangle law for difference. So, or you can also understand that E plus of minus Q is equal to the vector S, means that the vector S is P minus Q. Okay. So directly have, so in a sense we have done the derivation of this formula again. This is using the triangle law for difference. This is directly the formula of triangle law for difference of two vectors instead of sum. Yeah. Now square and add the first two equations. Okay. Yeah, Prince, I'll show you in the end again. So this is the same as this. So this is the first part where we are adding the two vectors P and Q and applying triangle law statement. So this is triangle law for sum of the two vectors. That is the resultant answer. It's the sum of the two vectors. Now likewise, below, you can see we are applying the triangle law for the difference. This vector S is now the difference of the two vectors P and Q. P plus or minus Q is the same thing as P minus Q. Then we can directly apply this formula, or we can derive this formula by this. Yes, now square and add both the equations directly. So we get yes, I will discuss question 10 also. So now next what we do here is equation 1 and 2 you square them and add them. So you get the so equation 1 square plus equation 2 square will give you r square plus s square is equal to 2 times. Okay, Prince, I'm waiting for you to finish the first part and then come to the second part. So, Prince, have you finished writing down the first part? Oh, so second part now is okay. So now let's come to the final question, the 10th one. So I'll explain the question, and I think you should be able to solve it yourself, the 10th one. Yeah, so what the 10th question is saying is that the resultant of two vectors, okay, of magnitude 10 each, okay, is also 10. Okay. So find the angle between them. So let's convert this question to this kind of language. Suppose R is the resultant of vectors E and B. It's saying that the magnitude of the resultant is also equal to 10, whereas the two vectors A and B are also equal to in magnitude. So find theta, that is the angle between vectors A and B. Try this out. So you'll understand that since all three vectors are 10, you can use geometry. The particular triangle that you get, the vector sum triangle, should be an equilateral triangle. So use the geometry. No, so that's why you have to be careful, because 60 degrees is the interior angle. But what is the angle between A and B? It's the exterior angle, no? So that will be 120 degrees. Okay. You understand that the vector triangle now has to look like this. This is vector A. Vector B has to be something like this, so that you get an equilateral triangle. And you add them. This is vector A of magnitude 10 units. This is vector B of magnitude 10 units. Now the condition for the resultant to also be of 10 units is that when you draw this vector here, which is the sum, it should form an equilateral triangle. This should be A plus B. Now this we want should also be 10. So that means it's an equilateral triangle, which means that what is this exterior angle, which is the angle between A and B, it's 120 degrees. So theta, the angle between A and B, is 120 degrees, because these three angles are equal. So theta will be 120. So this is the geometrical solution. You can also solve it algebraically. You can take the magnitude of resultant. Solving this, you will get 10 is equal to square root of 10 square plus 10 square plus 2 into 10 square cos theta. Squaring both sides and solving, you will get cos theta equal to minus half. Now, the moment cos theta is minus half, you realize that therefore theta is an obtuse angle, okay, such that cos theta is minus cos 180 minus theta, which is minus half. Okay. So that means cos of 180 minus theta is half, which means 180 minus theta is 60 degrees, which means theta is 120 degrees. Okay. So this is the way to solve the same thing now algebraically, using the triangle law statement. The root of a square plus b square plus 2ab cos theta formula. So using that, this is the way of solving this. So at this stage, both the methods should be clear to you. Though obviously we can see in this particular question, the geometrical method is much faster and easier. So with more practice and more number of worksheets as you do, you will gain that experience that in which question you should use the geometrical method, which question you should use the algebraic method to get the fastest solution. Okay. Okay, people, so hope this question is clear. Now we move on to the next thing in vector algebra. So next we will learn something called triangle inequality. So this comes from the statement that magnitude of a plus b is root of a square plus b square plus 2ab cos theta. So in this we can see that the maximum possible value of cos theta is plus 1, and that happens for theta equal to 0. Therefore, magnitude of a plus b's maximum value possible is equal to root of a square plus b square plus 2ab, and this occurs for theta equal to 0. Or in other words, magnitude of a plus b's maximum possible value is equal to magnitude of a plus magnitude of b, because this can be written as square root of a plus b whole square. So what this statement means now, that this statement means that this occurs for theta equal to 0. So in general, that is for all theta, a plus b का magnitude कभी इससे ज़्यादा नहीं हो सकता. So it is less than equal to a plus b. Okay. So basically this means something like this, that for example, suppose magnitude of a is 20 and magnitude of b is 15. That means magnitude of a plus b will always be less than equal to 35. Okay, so that means magnitude of a plus b cannot exceed 35, no matter whatever the value of whatever the angle theta between, कुछ भी हो theta, okay, but it cannot exceed 35. So the maximum limit of the sum of two vectors or the resultant's magnitude is the sum of their individual magnitudes. So this combined with another statement which we'll see about the minimum value is called the triangle inequality. So just make a note of this first thing. Acha, Akshat, we have done this part in the last lecture, is it? Let me just check the whiteboard notes. Okay, no problem. If we have done this part, we just look at some application questions based on this. Yeah, we've discussed about this. So let's treat this like a recap. So we've seen the derivation of this thing last time, and similarly we've also seen mod of a plus b's minimum possible value is difference of their magnitudes, and this occurs when theta is equal to 180 degrees. because cos theta's minimum possible value is -1 for theta equal to 180 degrees. So from that we saw that in general this set this was the statement of the triangle inequality, which you have correctly pointed out that we've done in the last class. So let's look at a question or two of the application of this before we move on to other things. Okay, so let's look at an example application. Given that A plus B plus C is equal to 0, that is the sum of these three vectors, the resultant sum of these three vectors is equal to 0. Okay. And magnitude of A is 2 and magnitude of B is 5. Okay. Then the magnitude of C may be 4, so 7, 9. So just tell me the right answers in this. Select the correct options. More than one option may be correct. Okay, more than one option may be correct. So look at all the options carefully. Yeah, think carefully of all the options. More than one option might be correct, people. Okay. So see, all you have to do here is you have to understand that E plus B plus C is equal to 0 is the same thing as saying that C is equal to minus of E plus B. Okay. So that is the same thing as saying that magnitude of the vector C is magnitude of minus E plus B. And you know that when we talk about magnitude, the minus sign is removed. So it is mod of E plus B. That means mod of C is equal to mod of E plus B. So therefore, mod of C cannot exceed the sum of their magnitudes and cannot be less than the difference of the magnitudes. Okay. So therefore, mod of C cannot exceed 7, but also cannot be less than 3. Okay. This. Therefore, C equal to 2 is not possible. C equal to 4 is possible. Okay. C equal to 7 is also possible, but C is equal to 9 is not possible. This is also possible, but sorry, 7 is possible, 9 is not possible. So the correct answers are only B and C. Yeah, so just go through the working prints, you will understand. So देखो statement मुझे दिया हुआ है कि A plus B plus C is 0. Okay. So उसका मतलब क्या हो गया? That the vector C is negative of the sum of A and B. So that means the magnitude of the vector C is equal to the magnitude of A plus B. Now I have that theorem that A plus B की inequality relations क्या होते हैं? It is less than equal to sum of A and B's magnitude and greater than equal to difference of A and B's magnitude. Okay. So here, this will mean that A plus B cannot exceed what? 5 and 2's sum, which is 7, or 5 and 2's difference, which is 3. Okay. So this lower limit is 3, the upper limit is 7. Now the same thing can be said about C. Okay, so C cannot be less than 3, and similarly it cannot be greater than 7. So out of the given options, you can see it cannot be 2, it cannot be 9, but it can be 4, it can be 7. So hope this is clear, people. So the answer you need to write is B and C, no beta. Which of these is possible? So B and C is possible because the options were this. Okay. So if this was more than one option correct question, you would tick mark this option and this mark option. Okay. नहीं वो नहीं कर सकते ना बेटा, because we don't know the angle between them. So we can only estimate. Okay. We can only estimate this. That see theta is not given, so we cannot calculate what mod C is. But we can say that okay, we can rule out कि 9 तो हो ही नहीं सकता है. Whatever be the angle theta, it is not possible for it to be 9 because it cannot exceed 7. And similarly, it's not possible for it to be 2 because no matter what the angle, it cannot be. So that's why the question is also asking what it may be which. It's not asking calculate the value. It's saying may be how much. You can see that yeah, it may be 4, it may be 7, but it just cannot be 9. It's not possible. It cannot be 2. Okay, so that is the meaning of this type of question. It's like a logical question. It's not a solving based question. It's a logical type of question. Okay. Now next in similar kind of analysis, we will see something called parallelogram law of vectors. For vector addition and subtraction. So unlike the triangle laws, what happens is here in one law itself or in one geometrical figure, which is the vector parallelogram, we are able to get both the sum and difference of two vectors. Okay? So given two vectors A and B, such that magnitude of vector A is denoted by capital U, magnitude of vector B is B, and theta is the angle between them. It turns out that if we draw the vectors, okay, so suppose these two vectors are given to us, this is one vector, this is another vector. Some arbitrarily they are just given to us. Now in parallelogram law, what we do is we construct a parallelogram such that A and B are adjacent sides. So a parallelogram is constructed with vectors A and B as adjacent sides from the vertex, let's say O. Okay. Let's say this is one of the vertices of the parallelogram. So from this vertex, we will construct both the vectors which were given to us above. So vector A will be here, and vector B, instead of drawing here, now we will construct them from the common origin. So vector B will be here. So after having drawn A and B as the adjacent sides, we can just draw two parallel lines, one line parallel to A, another line parallel to B. So we can just construct two sort of helping lines, and this is the angle theta between A and B. Now, if you look at the diagonals of this parallelogram, they actually represent individually the sum and the difference. So this particular diagonal now represents the resultant sum of the two vectors. and this particular diagonal represents the difference of the two vectors. And it's very easy to show why this is the case also, because we can individually construct the two triangles, one triangle for vector sum and one triangle for vector difference, and we'll see it will give us the same result. Okay. So what happens is, on constructing the vector parallelogram, okay, next what happens, the diagonals of the parallelogram give the sum and difference. Okay. So what happens is that what we call the primary diagonal, okay, that is the diagonal from the common origin from which we have drawn the two vectors A and B, okay, to the opposite vertex. That diagonal represents the sum A plus B. And the so-called secondary diagonal which is drawn from the head, the arrowhead of B to the arrowhead of E. This particular diagonal, now it represents the difference. So first just note down this theorem and the diagram for it, then we'll understand the logic of it, okay? The derivation and the logic of it. But how within the same parallelogram figure, we are getting both the sum and the difference. So note down the heading first. Parallelogram law for vector addition and subtraction, then I'll take you to the steps. So given two vectors A and B such that the magnitudes and the angle between them is known, the first step, it will come below. We construct a vector parallelogram, and then in that parallelogram we see that the two diagonals, each of them represents respectively the sum and the difference. Okay, so this is how we construct the parallelogram. It's constructed with A and B as adjacent sides from the vertex O, from the common vertex O. Okay, so is this clear, people? Okay, so let us understand how this is valid. Okay, why these diagonals form the sum and the difference. So let us look at the parallelogram with respect to the triangle law or the two triangle laws. Okay. So once again, if we have two arbitrary vectors A and B, suppose, now if we were to find out A plus B by triangle law, what we would have done? We would have drawn the first vector E like this and drawn the second vector to its head. Where this angle is the angle between them, theta, and this particular side will now become the sum E plus B. And this angle is that alpha. Now in parallelogram law, what we are doing, and try to understand why it's the same thing actually. It's only the geometrical shape we are drawing is different. But the triangle is there hidden within the parallelogram. Because we are drawing the vectors A and B like this. Then we are constructing a parallelogram by computing these parallel sides. Okay. And then we are seeing that apparently this vector from the common origin to the opposite side, this should represent the sum. So I think now you can see very clearly in the diagram why they are exactly the same, and this angle is alpha. Okay, because you can see here that E angle with the theta ही होगा ना, because these two sides are parallel, and this is also magnitude E, this is also magnitude A, here this is also magnitude A, this is also magnitude. So basically what we can see is that within the parallelogram itself you have that triangle hidden. This triangle is nothing but same as this triangle. That is why this diagonal is the sum. Okay. So that is the logic of it. So if you compare the parallelogram law with the triangle law for the sum, you can see one contains the other. Okay. And that is why it's exactly the same thing, but it's just expressed in terms of a parallelogram. Here it's expressed in terms of a triangle. And the formula is common, that mod of A plus B is equal to root of A square plus B square plus 2ab cos theta, and that tan alpha is equal to b sin theta upon A plus B cos theta. So make a quick note of this, and then we'll see similarly why the difference is also the same. I mean, the difference triangle, if we compare with the secondary diagonal wala triangle, again you'll see that the logic of it is that the triangle that we use to construct to find the difference of two vectors, that triangle is also hidden within the parallelogram. So ultimately, it's like the parallelogram is a combination of the two triangles. The one triangle that we use to find the resultant sum, and the other type of triangle that we use to find the difference of A and B. Okay, people, so hope you are clear with this comparison. Okay, so just give me a few seconds here. I will restart the screen. Okay, now similarly, as I said, let's also understand the comparison of the triangle law for difference of two vectors and the parallelogram law. So we want to construct the difference using our two vectors. So by triangle method, we would have drawn first the vector E, and then to that we would have added the vector minus of B. So if B was like that, then minus of B would look like this. So this is E. This would be the vector minus of B, such that this angle here was 180 minus theta, because the angle between A and B, which would have been in this direction, this angle was theta. So this is 180 minus theta. And in this diagram now you can see that the difference of the two vectors is this one. Okay. This becomes A plus of minus B or A minus B. And this angle we had written as beta, where we saw that the formula was that A minus B has a magnitude of root of A square plus B square minus 2AB cos theta. And tan beta was B sin theta upon A minus B cos theta. Now let's see how this works out with the parallelogram law. This is the triangle law method. Now by the parallelogram law, how that will look, let's understand. So we draw these two, the two vectors A and B from a common origin. We don't draw minus B. We draw the vector A and the vector B. So like this, let's say, where this angle is theta. We draw them from a common origin. Then we draw the parallel sides to complete the parallelogram. And then we said that in this parallelogram, it is the secondary diagonal, the one which is going from the head of B to the head of A, that represents the difference. So the primary diagonal was the sum. So the secondary diagonal, this one, is representing the difference of vectors. So again, you can see by comparison of this figure with this, it's actually the same thing. It's exactly the same. This is that same angle beta we are talking about. Okay. And this exterior angle here is the same as this one here. 180 minus theta. So you can see that this triangle is actually contained within the parallelogram. This triangle is there within the parallelogram. So that's why. So the thing is, you take the sum triangle and the difference triangle and combine them, you sort of get the vector parallelogram. So what is the advantage of the parallelogram as a diagram? Because it gives us the same diagram with the same with the two quantities, sum and difference. Now, if I go with triangle law, I have to separately construct a triangle for sum and separately construct a triangle for difference. But the advantage of parallelogram law is that in the same figure, now I can draw this diagonal, the primary diagonal as the sum and the secondary diagonal as the difference, and we can see both the things, the resultant sum as well as the difference within the same geometrical shape. I don't have to draw two separate geometrical shapes. So that is the advantage of the parallelogram law. So in certain types of logical questions, that becomes very useful. That you can draw one diagram, or in the same diagram you are able to geometrically see what is the sum of the two vectors and what is the difference. So that is the reason why we have this separate statement of the parallelogram law. Okay, so hope this point is clear to all of you. So we'll understand, what kind of properties are easy to understand when we use the parallelogram to visualize the sum and difference rather than use the triangles. So certain inherent properties of vector operations become very easy to understand when we look at them with respect to the parallelogram rather than with respect to two separate triangles. So hope this part is clear, people. So with this, you can quickly see how this triangle is the same as this. So this particular diagonal is representing the difference. Whereas earlier we compared this triangle was the same as this. So the primary diagonal is representing the sum. Okay. So now that we have understood this, we can see some important properties of vector operations using parallelogram. So some properties. So we can actually compare three types of parallelograms. One is, let's say, the middle case where A and B are perpendicular vectors. So the moment A and B are perpendicular vectors, geometrically you can understand that your parallelogram has become a special type of parallelogram, which is a rectangle. Okay, so that itself is going to make things easier to figure out. What happens when A is perpendicular to B? So we can figure that thing out in terms of vector algebra, because in terms of geometry, it's become a rectangle. So A is equal to B, A is perpendicular to B, then we have that very interesting property that the diagonals are of equal length. And the length of the diagonals is how much? It is root of A square plus B square. So A minus B का जो length है, जो magnitude है, वो A plus B के magnitude के equal हो जाता है. But in which case? When it is a rectangle. So for that to happen, the theta has to be 90 degrees. So for this case, for example, we can see that for theta equal to 90 degrees, that is A is perpendicular to B, magnitude of A plus B becomes equal to magnitude of A minus B, becomes equal to root of A square plus B square. Okay. Because the parallelogram becomes a rectangle. You can apply the formula of triangle law also and understand the same thing. But this becomes so easy to visualize once you are thinking of the parallelogram law. But similarly, if we take the case where theta is acute, or let's take the case where theta is, let's take theta as acute over here. We take this kind of a case. Just give me a moment, okay? Then we'll compare the things together and we'll understand everything. So take a case like this. Then you can see that the angle between the two vectors is an acute angle. Theta is less than 90 degrees. Okay. So that sort of a parallelogram looks like this. And you can easily understand that in this parallelogram, which is the longer diagonal? The primary diagonal is the longer one. The secondary one is the shorter one. So it has that property, okay, that when theta is acute, A plus B has a larger magnitude compared to A minus B. So instead of, in the formula worrying about, okay, cos theta is positive, so A plus B will have a positive term, A minus B will have a negative term and all that. Don't have to do that. You can just understand from the geometry of the shape only that when this is happening, for this case now, for theta less than 90 or acute angle, what happens is that A plus B is greater in length compared to A minus B. Because you can see that in this parallelogram, the primary diagonal will be longer, okay, because theta is acute. Okay. Whereas you compare both of these now with the case where theta is obtuse. वो कैसा parallelogram दिखेगा? It will look like this. This vector A, B will be somewhere here because theta is now obtuse. So we take a case where theta is obtuse, less than equal to 180 degrees. Then here you are seeing it is the other way around. The longer diagonal is which one? It is the secondary diagonal. It's the difference which is going to be longer. So now the primary diagonal is the shorter one. It's like this. And the secondary diagonal is the longer one. So you can see that theta is obtuse. So when that happens, immediately E plus B becomes less than E minus B. Whereas when theta is acute, A plus B is longer. And when theta is 90, that is when A plus B is exactly equal to A minus B in magnitude, which is root of A square plus B square. So this is an important set of properties of vector operations, which are very easy to remember if you just visualize them in terms of parallelogram. Instead of memorizing these properties, you can just remember in terms of parallelogram. In this case, it becomes a rectangle. In this case, it's a parallelogram where the primary diagonal is longer. So obviously A plus B is longer. If theta is obtuse, it becomes stretched in this way. So the secondary diagonal becomes longer. A plus B becomes less in magnitude compared to A minus B. So these properties are easy to understand using the parallelogram. So this is just one of the type of situations in which we can make use of parallelogram law to understand things more easily. Because in the same figure, you are able to understand both the sum and the difference. Okay, so just make a note of this, people. So we'll come to the conclusion of today's lecture. So I'll be giving you a worksheet which will have some applications of component algebra as well as these parallelogram law statements and these kind of properties that we discussed today. And next lecture we'll take it from there. And subsequently in the next one after that, we will start with the products of vectors. First we'll do some more work with respect to sum and difference using component algebra and some of these properties. Okay, so one more important thing that we can understand from this now is that in the case of acute angle, okay, this case over here, magnitude of A plus B actually becomes greater than root of A square plus B square because cos theta is positive. It is greater than root of A square plus B square, whereas magnitude of A minus B becomes less than root of A square plus B square. Okay. So along with this, you also have these two because cos theta is a positive quantity. If you apply it in the formula of triangle law, you'll understand why this happens. Whereas here, both of them are equal, so they're equal to root of A square plus B square. And again, when theta becomes obtuse, what happens is that mod of A plus B becomes less than root of A square plus B square because cos theta is a negative quantity when it's obtuse. And same reason why mod of A minus B becomes greater than root of A square plus B square. So not only A plus B is less than A minus B, A plus b's magnitude is less than root of a square plus b square, and a minus b's magnitude is greater than root of a square plus b square. Whereas when it's 90 degrees, they are both equal, and that equal value is equal to how much? Root of a square plus b square. So you additionally also have the comparison of these terms with respect to root of a square plus b square. In the case where it's acute, in the case where it's obtuse, and in the case where they are perfectly perpendicular. This is part of this property. Okay, people. So with that, we come to a conclusion of today's lecture. So as I told you, you will have another worksheet to try out and work out questions from before the next lecture. So immediately after today's lecture, I'll be sending you that worksheet. So try to attempt the questions in the next 2 or 3 days and send me any doubts or difficulties that you have over WhatsApp. I'll help you out with that. Okay. That's it for today, people. All the best and stay safe.